Alright, good morning. Today is the 29th of June, 2021. I have to be focused because I only have 15 minutes to do this. We're going to try reverse linked list 2, a medium problem on LeetCode, and try to find out what's going on here. Okay, given the head of a singly linked list and two integers, left and right, where left is less than right, reverse the nodes from position left to position right and return the reversed list. Okay, alright, so our input is 1, 2, 3, 4, 5, left is 2, right is 4. Output is 1, 4, 3, 2, 5. Okay. The number of nodes is n. We're going between 1 and 500, and the value is between minus 500 and positive 500. Left is less than or equal to right, which is less than or equal to n. Can we do it in one pass? I was sort of thinking about doing it in one pass. Anyway. Okay, so first things first, let us, because we're in Facebook, interviewing theoretically for a company similar to Facebook, let's go into CoderPad, which is the format we'll be using. We won't necessarily have access to our compiler. So we do have our we don't need to instantiate a list node of 5, but that's instructions on how to instantiate it. But we can do our test cases. Node 1 equals list node 1. Two, 3, 4, and 5. Our pointer head equals n1. It's our list node. Our pointer points to head, and we have to connect everything. n1 next equals n2. n2 next equals n3. I can't wait to get these mechanical keyboard upgrades. I keep doing all these mistypes. They're coming on Thursday. n4 next equals n5, and then n5 next is already assigned to be null. So now we have 4 connections, 1, 2, 3, 4, and 5 in our list node, and we're going to declare the function reverse between. It will input a head of nullable type list node, left of type int, a right of type int, and we're going to return the new head. Val node equals head We're going to call it a node, or we're going to call it P1. We're going to make use of P's later, probably, so we'll just call it node. And then return node, and then we will call... So this is the function that's going to be called by our... this class definition actually goes outside of main. It could go inside main, but we'll put it out of main. It could be a data class too, but we're not going to worry about that right now. We are already 5 minutes in, we haven't even started thinking about this. Reverse between, and then we are going to, in function main, we're going to print line reverse between and we're going to input our head, and then we're going to switch between 2 and 4. Okay, so there's a test case. That's an okay starting point for a test case. Okay, let's see. We're going to declare a function traverse, which we'll use to traverse the list node. We're shadowing names here. New head. And we're going to return new head. If head equals null, it shouldn't be from the constraints, but if it's null, we'll return null. We're going to try to do this in one pass, because I think that's a good solution anyway. Traverse node, we never did this. We never assigned node to be of type nullable type list node. And we're going to have to store a position somehow. We can have a position I. We'll do it one indexed, just to keep things simple. And we will call our head and pass in I equals 0. let's see. We'll recursively call traverse I plus 1. We'll call that the pointer 1. Now I'm not sure if we can use 2 pointers and then do it in one pass. I believe we could. But I don't think that we'll need to. Okay, so as we call traverse, we'll traverse to 5. It will return type list node. If node next equals null, return node. We want node to be of non-nullable type list node. And it will be a non-nullable type list node. To our non-null assertion there. Now we're dealing with non-nullable types. Great. Okay, if node next is equal to null, we'll return node. So at this point, as we're traversing, 5 will return 5 to 4. And then 4 will return 4 to 3. Let's pass our actual correct variables into traverse now. Okay, P1. Okay, we're traversing head 1. We're traversing node I equals 2. We're traversing node 3, I equals 3. We're traversing 4, I equals 4. And we're traversing I at I equals 5. Um, 5 will return 5 to 4. P1 is now 5 in traverse of 4. And we don't want to do anything there. We're switching 4, 3, and 2. When 4 returns to 3, if I is less than right, we're going to be actually performing 2 reversals. And I is greater than left. We'll have to check the edge cases on these. We're running out of time though. Okay, when 4 returns to 3, P1 is 4, and node is 3. We will do P1 next equals node. Three will likewise reverse to 2. And 2 will continue to point to 1. Except we now have 1 to nothing. We have to connect 1 to 4 somehow. One, 4, 3. 1, 4, 3, 2. And then 2 has to connect to 5. We can do val end of type list node equals null if node next equals null and equals node. Else if I equals left node next equals end. Let's assign a val last reversed of type node list node equals null. Equals node, and then else if I equals right, last reversed equals node. Okay, now we saved a couple of pointers. So if I is equal to 1, 2, 3, 4, 5, traverse 5 will return to 4 and do nothing. P1 is now 5. So the arrow isn't reversed, but we've saved the pointer to the last reversed. And then we iterated through reversing until we got our first reversed. When 2 returns to 1. Okay, let's see. When 2 returns to 3, okay, so let's see. 5 returns to 4. No change. But because I is 4, last reversed is saved. Last. 4 returns to 3. And 3 is between 2 and 4. So 3 is reversed. P1 next equals node. When 3 returns to 2, P1 is 3, and I is 2, so I is greater than or equal to left. So we want to reverse the direction. But we want to remove this from the else if. because we want to remember I equals left. If I is equal to 2, we do the first reversed. And then, when 2 is returned to 1, 1 is less than left, so nothing happens. It's okay, cool. Nothing happens. And then at the end of traverse, after traverse is called, then we have to reconnect. Well, let's do this first. Let's reconnect. One to 4. These should also be variables and not values because they're going to be reassigned. If I is equal to right plus 1, first after reverse equals P1 equals node. I equals left minus 1. Let's think about our edge cases if we're swapping first and last. In a minute. We still have to think about our edge cases. Last before, reverse, next. Equals last reversed, and then first after reverse, last reverse. Oh, first reversed, next equals 5. Okay, I almost certainly made a mistake here. Really slow. But I believe since we're traversing these nodes, let's see. Our edge case, I think we're okay for the Goldilocks case, but we're probably off on the edge cases. Because if we're going to reverse 1 through 5 from say 0 and 3, we'll traverse all of them. We'll hit 5. There'll be no change in reassignment when 5 returns to 4. But when 4 returns to 3, first after reverse is saved as 4. no change to the direction there. But when 3 returns to 2, we will reverse direction. And save first reversed. Two will return to 1. And 1 will also be reversed. Except we indexed our guys with 1, start index of 1. And when we assigned our next of 3 to 2, we broke this link as well. If I equals, okay, we have last reversed assigned at 3. If I is equal to left, first reversed is 1. First reversed next is equal to first after reverse. So we will relink 1 to 4. Last before reverse is never called. If last before reverse is non-null, we'll do our normal case, else we'll do our edge case, which is, let's see. New head equals last reversed. H3 goes to 2, goes to 1, goes to 4, and goes to 5. So we have our we have one of our edge cases covered, and the other one's going to be similar. Your first after reversed is non-null. We'll do our Goldilocks case. Else let's go through our case of between 3 and 5. If I is less than or equal to left, or if I is greater than or equal to left, and less than or equal to right, or less than right, else if I equals to right, last reversed is assigned here. I traverses 4 returns to 5. And the position is reversed. Three returns to 4, nothing special happens. 4 now points to 3. This link is broken and 4 points to 3. Three returns to 2. We'll break this. 2 goes to 3. Or 3 now points to 2. And then 3 is saved as first reversed. No change. First before reverse, or last before reverse. And 2 returns to 1 with no change. So here we have 1 points to 2. Two points to 0 points to 1. Head points to 1, 2. Okay. Else if first after reversed is null, then last before reverse next equals equals end. I think we're okay. Actually, I think I probably made a mistake, but this is the best solution that I can come up with. So, let's do our initial link. And lastly, let's test the case of reset all our nexts. And do the test case between 1 and 5. Okay, so for the test case between 1 and 5, 1... Okay, so we traverse through. And we didn't save the end. But as 5 returns to 4, next will break and point to 5. Okay, this feels better. As 4 returns to 3, 3 next will break, and 3 will now point to 4. Two next will break, and now point to 3. This is the end and the last traversed. Equals right. I screwed that up. Okay, when I equals 5, end is equal to node, we have last reverse equals null last reversed. And 5 also points to null. Okay. If I is equal to right, this never executes. Gosh, this is screwy. I feel like I'm close, but my edge cases are still screwed up. Five returns to 4. 5 next breaks, and 5 now points to 4. Four returns to 3. 4 next breaks, and now points to 3. 3 returns to 2. 3 next breaks and points to 2. 2 returns to 1. 2 next breaks and points to 1. And first reversed is node. You have a couple of problems. Okay, so our new head is being assigned as 5. Last before reverse is end. Okay, CC. If last before reversed is null, view head equals last traversed. So our head moves from 1 to last traversed. I don't know. I ran out of time. This is taking way too long. I screwed it up. This is probably pretty hard. Well, let's stop the stream now. We'll look at the solution later. In the next video. And then we'll reattempt it the easy way. Okay. We came close-ish, but we got really screwed up on the edge cases. Alright, that's it for now.